Alright, today we're going to talk about graphs of linear inequalities. I had a video up and somehow it got corrupted, so I'm recording it again. And I threw in some other videos from YouTube in the video section too, just in case. But I'm doing this a little bit different. I'm going to record it and then upload it to YouTube and then bring it into Canvas, and hopefully it won't corrupt that way. So, before in our class we've graphed inequalities with one variable and the number line. Now we're going to look at graphing a linear inequality with two variables. In order to do that, we'll graph them like we did the lines. I highly recommend that you get or print out some graph paper. If you're doing this by hand, you can search free printable graph paper, and there's tons of options. But I really like to use Desmos.com. It's really the easiest way to do this. I highly suggest that you use Desmos.com, but if you want to do them by hand, I'm going to show both. So I have this, so it says graph 3x plus 4y is greater than or equal to 12. So we're going to graph the related equation, and we're going to use a solid line because this equal sign here, and that indicates that the line is included in the solution set. Now we by now should know how to solve an equation, so if I solve for the boundary equation, I get y equals negative 3 fourths x plus 3. And so I'm going to go ahead and graph that. So I have, if I put 0 in here, I get y is equal to negative 3 fourths times 0 plus 3, which equals 3, so that gives me the 0.03. And then I see that my slope is negative 3 fourths. So I'm going to start at 0.3. And so this can be either negative 3 over 4 or 3 over negative 4. However, so that helps us. Remember, the slope gives us walking directions. So for every 3 I go down, I'm going to go right 4. So I'm going to go 1, 2, 1, 2, 3, and then over 1, 2, 3, 4. And you really only need 2 points for graph. Sometimes I like to have 3 just because I'm tired or I do silly things. And I know we have said that equal sign is right there, so I know I include it in the boundary point, or it's a solid line. If it was just greater than, we would do a dashed line. So the next thing we want to do is determine which half plane to shade, and to do this we test a point on either side. I like to use 0, 0 because it makes our calculations easy, but you can use whatever you want. So let's test the point 0, 0. So I'm going to put it back into the original equation. So 3 times 0 plus 4 times 0 should be greater than or equal to 12. And so that gives 0 is greater than or equal to 12, and that is a false statement because we know 0 is not bigger than 12. So we shade on the side that does not contain the point 0, 0. So 0, 0 is here, so I know because of my test I need to shade that side. Okay? So when I type it into Desmos.com, so I did the 3x plus 4y greater than or equal to 12, and I hit enter. It gave me this beautiful graph here. solid line, everything shaded to the right, which is a nicer version of what we did by hand. Alright. And I have a lot of people say, well, I think that using a calculator or online calculator is cheating, and I often remind them that I have written this course knowing that you would have access to these things. So it's not cheating if I suggest that you use it. Okay, Desmos is a great utility, and a lot of people seem to struggle with graphing, so this is really helpful. Alright, so now I have another example. 2x plus y is less than 4. So we're going to graph the related equation, 2x plus y equal to 4, but we're going to use a dashed line because there's no equal sign over here. And that indicates that the line is not part of the solution set. Anything up close to the line is, but not the line. So I solved the equation for y, and it gives me negative 2x plus 4, and you can graph however you like. If I put 0 for my intercept, if I let x equal to 0, then I get y is equal to negative 2 times 0 plus 4, or y equals 4. So that gives me the intercept 0, 4. And my slope is negative 2. So I can rewrite that as negative 2 over 1 or 2 over negative 1. And that, remember, our intercept gives us our starting point, and our slope gives us the walking directions. So I go to 0, 4, and I need at least one more point. So I'm going to use this one for every 2 I go down. 1, 2, I'm going to go over 1. And we'll do another point. I'm going to go down 1, 2 over 1. And when I draw my line here, I'm going to make a dashed line because there's no equal sign in the inequality. And then we're going to do a test point. I'm going to choose 0, 0 again because I'm lazy and that makes my math easy. I'm going to test 0, 0. I'm going to put it into the original inequality. So 2 times 0 plus 0 should be equal or less than 4. So 0 plus 0 should be less than 4. And in fact, 0 is less than 4, so this is a true statement. So shade the side that contains 0, 0. So 0, 0 is the origin, it's right here, so I know that I'm going to shade that side. And this is what it gives you if you type that into Desmos. 2x plus y is less than 4, and if you can see that these are little dashed lines and everything to the left is included, which is just a nicer version of what we just did. Alright, so just like a video game, we get one level done, and the next level comes out as faster and harder. So now we want to solve the systems of linear equations. And so this is where both lines are true at the same time. It's kind of like a Venn diagram. You want to know where they overlap. So a system of inequalities consists of 2 or more inequalities considered simultaneously. A solution of a system of inequalities is an ordered pair that is a solution of each inequality in the system. In other words, we're looking where the solutions or shading overlaps. The graph of a system of linear inequalities, or to graph it, we graph each inequality separately and then determine the region that is common to all the solutions in the solution set. So this one gets a little tricky. We can still do it. So the first time I'm going to I'm going to look at x plus y less than or equal to 4, and I'm going to solve it for y. Our boundary line is going to be y equals negative x plus 4, and since there's an equal sign here, I know it's going to be solid. And if I put 0 in here, I get y equals 0 plus 4, or y equals 4, so that gives me the point 0, 4 to start. And then our slope is negative 1, which is the same as 1 over negative 1, or negative 1 over 1. So this is our starting point, and these are our walking directions. So I'm going to go to 0, 4. 1, 2, 3, 4. And so for every one I go down, I go over 1. For every one I go down, I go over 1. Every one I go down, I go over 1. Keep going. That one was an easy walk, so I just kept going until I hit the other intercept. And it's going to be a solid line. And then I'm going to test my point. 0, 0 into this original guy here, and I have 0 plus 0 is less than or equal to 4, and in fact 0 is less than or equal to 4. That's a true statement, so I'm going to shade everything on the side that contains the point 0, 0, which is the origin. So now I'm going to look at the second one in the system. I have x minus y greater than or equal to 2. I know that the boundary line is going to be solid because of this equal sign right there. And to solve this guy, I'm going to, so we can do it different ways. I don't like having to flip an inequality sign, so I'm going to add y to both sides, and I get x greater than equal to y plus 2, and then subtract 2 from both sides, and I get x minus 2 greater than or equal to y. So my boundary line will be y is equal to x minus 2. So if I put 0 in here, I get y equals negative 2. So I have the point 0, negative 2, and then my slope is 1. So remember, it's the same as 1 over 1. So I'm going to come over here to 0, negative 2. And for every one I go up, I go over 1. Every one I go up, 1 up, 1 up. Make sure I'm just staying on the right ones here. And I'm going to make a solid line. So when you guys are doing this on your exam, it's going to give you two options. It's going to give you two different ones with the same where they intersect right here, but one's going to have the correct lines and the other one isn't, so pay close attention to that. So let's test to see which side we shade. I'm going to do 0, 0 again. I put it back into here, and I get 0 minus 0 is greater than or equal to 2. 0, in fact, is not greater than or equal to 2. This is false. So I'm going to shade the side of this line that does not contain 0, 0. So remember, we're looking at this line, so I'm going to shade the right hand side, and I'm going to do like swirlies instead of hash marks. And Amy, why did you do that? Because I said this is like a Venn diagram, and we want to know where they overlap. So where my lines and swirlies overlap is this section right here. So I'm going to go ahead and erase the parts that don't overlap. Sometimes doing this with colored pencils is good because then you can see where the overlap is. And so this area in here is my answer. If that was too much drama for you, remember that we can put that in Desmos.com. So the first inequality they did in purple. The second one they did in gray. And if you don't like the colors in Desmos, you can come in here and change the colors. We want, on the homeworks and the graphs, we want to know where they overlap. So you would ignore these parts, and this right here would be your answer. And any of these points here on the line, if you need to know what it is, all you have to do is click on that, and Desmos will give you the coordinates. Desmos should be your best friend. Okay, let's look at another one. I think this is our last one. All right. So we have two inequalities. I have y greater than x plus 1. So I know that the boundary line is, I got a little carried away there. Boundary line is going to be dashed. Why is it dashed? Because there's no equal sign right there. And so it's going to be y equal to x plus 1. I know that it has an intercept of 0, 1, and it has a slope of 1, which is 1 over 1. So I'm going to go ahead and graph that. I have 0, 1. And for every 1 I go up, I go over. For every 1 I go up, I go over. And here is my dashed line. Oh, and we can write this as negative 1 over negative 1 if you want, because two negatives make a positive. I guess I should show you that. So if I went from the intercept here, every 1 I go down, I go over 1. Every 1 I go down, I go over 1. So you can walk either way. I know this is a dashed line. So that's my first one. And now we're going to test it with the point 0, 0. So 0 should be greater than 0 plus 1. And we know 0 is not greater than 1, so this is false. So we're going to shade other side. So this is the side that has 0, 0. It was false, so I need to shade this other side here. And I'm, like before, I'm going to use lines to shade it. Alright, so let's look at the other one. Y is less than or equal to 2 minus x. This has an equal sign, so my boundary line is solid. And it's y equal to 2 minus x, or y is equal to negative x plus 2. If I put 0 in for x, I get y equals 2, so that's the point 0, 2. And my slope is negative 1, which is 1 over negative 1, or negative 1 over 1. I'm going to go to 0, 2 here. And for every 1 I go down, I'm going to go to the right one. For every 1 I go down, I'm going to go to the right one. So that gives me 3 points. You only need 2, but 3 is the CYA point. If you don't know what CYA is, you'll just have to look it up. Alright, and now I'm going to test the point 0, 0 to see which side I should shade. And so I'm going to put it back into here. So 0 should be less than or equal to 2 minus 0. And in fact, 0 is not less than equal. Actually, it is. So 0 is less than or equal to 2. And so this is a true statement. So we're going to shade the side that with or contains 0, 0. So that means this is my line, 0, 0 is here. So we're going to shade that side, and I'm going to do it with circles or squigglies. And so I can see that the only place where my lines and my squigglies intersect is this area right here. So the rest of this I can erase. Because remember, the answer is only the place where they intersect or where they overlap, like a Venn diagram. So that is my answer. And if I put this lovely thing in Desmos, here's my first one. See, it's got the dashed lines and it is shaded here. This is the second one. It has a solid line. And this place where it's darkest, that is your answer right there. Okay, so we'd ignore these parts, and that is your answer. Alright, if you have any questions, come see me in office hours or drop me a Canvas message and we can talk about this some more.